Hey, conceptual physics students, how about some hints about maybe the shortest assignment of the year? It's not all that difficult in and I think I can help you a little bit here, not with all of the problems, but how about the ones involving problem solving? So let's look first at page 81 through 85, the chapter 5 assignment. Okay, so there are some questions first, but let's look at number 40. Number 40 begins one that's numerical. So in this question, there's a helicopter, and the assumption that it's moving 15 meters per second horizontally, though they don't say that. So we're plunging. So it's very useful to look at the knowns and unknowns like we've done all along. The beginning velocity horizontally was 15 meters per second, and the time it takes is 2 seconds. When you look on your formula sheet, if they say, please tell me what the DH is, then it's very simply going to be a formula. Let's decrease this. So we're looking for a formula that has DH, and that would be simply this one. So since they give us DH, since we're solving for DH, take the 15 and the 2, and that's easy mathematics. A much tougher question would be number 42. So if you take a look at number 42, Harry and Angela are wondering if they'll be successful jumping out of the balcony, and probably an error to try that anyway. But jumping horizontally means a very important point. When you go horizontally at the beginning, that means that you have a beginning vertical velocity of 0. So in fact, if you don't know this, if this is not something you utilize, you can't solve the rest of the problem. Now, a picture that would go with this is kind of like this. Instead of a full parabola, you are going to go just down like this, okay? So notice they have told us 2 pieces of very important information. Here's how high that they were, and that's 45 meters. And how far away were they from the bottom, and that's 15 meters. So notice that they are giving us the dV, the vertical displacement. And they are also telling us what the d sub h is. That's 15. Very important, because if you look at this formula, the vertical displacement formula, notice if the VV1 is 0, this whole term simply drops out. You can cancel it out. Now notice this. It becomes 45 equals 1/2, and you're aware the g is 9.8, or negative, you choose. But in this case, since everything's downward, I would use positive 9.8. And what's the only unknown here? That would be t. So if you multiply both sides by 2 and divide by g, there's no reason why you can't take the square root as your final step. Then when you find t equals something, you will find what t is. Why not use that t in this formula to solve for the unknown velocity that you'll need to jump out jump off the balcony, which again I advise against. Number 44 is the same exact kind of problem. There are some different numbers, but that's all we have, is slightly different numbers. So that shouldn't be too bad. Now, if you look at page 182 to 187, there weren't very many problems that I asked there. There were some conceptual ones, and I'll ask you to look at that. But the only technique for any of these that you will use is the centripetal force formula. So the force of anything that goes in a circle, if you have something going in a circle, recall, the velocity goes tangent to the circle, but the centripetal force and acceleration are pulling toward the center. And the amount of the centripetal force is the mass of what's going around, the velocity squared divided by the radius, and all of number 23, 24, and 26 behave the same in the solution of that. I hope this helps you.